So the very first thing that I would want to put down in my proof, my very first statement should be what? The given information. So angle ABE and DBC are right angles. And what reason can I give for that statement? It is my given, yes. What other statement can I fill in right now? What it says I am supposed to prove, yes. So the measurement of angle ABD is equal to the measurement of angle EBC. Can I put a reason for that yet? No. I can't put that reason down until I get to the very, very end. I have to see what the step above it says to tell me why I'm allowed to take this last leap. So let's see what we can say. It says that ABE and DBC are right angles. What does it mean for something to be a right angle? It's equal to 90 degrees. So the measurement of angle ABE is 90 degrees. And the measurement of angle DBC is 90 degrees. What are we using to be able to say that? Close. We weren't told at the beginning that they were congruent angles. What were we told about them? Close. Complementary means what? They add up to 90. Do I have two angles that are adding up to 90 here? No, I have two angles that just are 90. Definition of a right angle. Definition of right angle. Okay. Let's see, where to go from here. Looking at where I want to be at the end, I want ABD is equal to EBC. Right now I have two separate equations, right? I have an equal sign over here, ABE is equal to 90. And I have an equal sign over here, DBC is also equal to 90. Well, if ABE is a 90-degree angle, and the measurement of angle DBC is also 90 degrees, then what else do I know about ABE and DBC? They're equal to each other. So the measurement of angle ABE is equal to the measurement of angle DBC. What are we using to make that statement? Why would I be allowed to say that ABE has the same measurement as DBC? Because they're not segments. They are congruent angles. I know they're congruent now that I've said this, but I can't use definition of congruent angles to justify why I'm able to say this. Look at what we knew right before this. What did we say in statement number 2? We said that they were both equal to 90 degrees. And then in statement 3, we said that means they have to be equal to each other. If this thing is equal to 90, and this other thing is also equal to 90, Why would they be equal to each other?
Substitution.
Substitution. Or this is another situation where I could use what other reason? Transitive property. So this is the substitution property. Or you could use the transitive property. Everywhere that we can use transitive property, we can call it substitution. We could use that property instead. But not everywhere that we would use substitution can we call it transitive. Transitive is specifically when I have three things. If you look at this line up here, I have an angle ABE. I have 90 degrees written twice, but it's the same thing written in two spots. So that's one other object. And then I have angle DBC. So I have three things here. These two angles, and then a measurement of 90 degrees. So I can use transitive property there. If you have more than three things, you have to call it substitution. All right. Let's go look at the picture now, because somehow I want to get angle ABD. Let's look at the picture and find that. Angle ABD, this little angle right here. And I want to say that the measurement of that angle is equal to EBC, which is this little angle over here. But we weren't told about those two little angles. We were told about ABE. I want you to ignore this part for just a moment. What is it that we know about ABE again? It's a right angle. It's equal to 90 degrees. Is it made up of smaller angles? What are the two smaller angles that are being put together to make ABE? Yes, angle ABD. So the measurement of angle ABD plus the measurement of angle DBE is equal to the measurement of angle ABE. So let me show you what we just wrote. ABD, this one right here, plus DBE, this one right here, gives us this angle. Can I make a similar statement about angle DBC? Yes. Well, what two angles make up that one? Yes. The measurement of angle DBE plus the measurement of angle EBC is equal to the measurement of angle DBC. Now I want to look at both of those statements. They use the exact same reasoning. I was taking two smaller angles, putting them together to make a larger angle. Yes. I want you guys to look at that red paper. What would allow me to take two smaller angles, add them together, and say that those measurements added together gives me the measurement of a third larger angle? The angle addition postulate, yes. Let me write it down and then I'll re-explain. The angle addition postulate is similar to my segment addition postulate. Segment addition postulate lets me take two smaller segments that are side by side. They touch each other at a point. I can add their measurements together and get the size of the larger segment that they make together. angle addition postulate is very similar to that. It lets me take the measurement of two smaller adjacent angles, so like this angle right here, DBE, and this angle right here, EBC. They are adjacent, they share this ray, BE, and together they make this larger angle, DBC. That's what angle addition postulate allows me to do. All right, so let's look now. What can we say? I want to get to where I have the measurement of angle ABD over here on the left. When I look at statement number 3, I have ABE on the left. That's close, but that's not exactly what I want. Can I replace angle ABE with something? Do I know something that's the same size as ABE? That would have ABD in it? Because I want ABD over here on the left. What do I know of that's the same size as ABE? ABD plus DBE. So this can take the place of angle ABE. So instead of ABE over on the left, I'm going to have the measurement of angle ABD plus the measurement of angle DBE. So ABE is the same as ABD plus DBE, so I put it in that spot. What am I using to be able to do that? Substitution. Can I say something similar about angle DBC? Do I know something that's the same size as DBC? What is the same size? DBE plus EBC, yes. So the measurement of angle DBE plus the measurement of angle EBC, and I'm running out of room writing this in here. Do the best I can. The very last one does say EBC, yes. So we know that these things are the same. This got put in its place. What did you guys just say we were using there? Substitution. This is one of those situations where I could not call this transitive property. I have ABE, that gets treated as one object. I have ABD plus DBE, that gets treated as one thing. DBC gets treated as one object. And DBE plus EBC gets treated as one object. So now we have made this substitution. I want EBC alone by itself on the right-hand side. Do I have EBC on the right-hand side in step 5? Yes. I have EBC and EBC. I want ABD on the left-hand side. Do I have ABD on the left-hand side in step 5? Yes, right here. ABD and ABD. But statement 5 has a lot more going on. What else is going on in statement 5 on the left and on the right? The addition. Angle DBE is there. And on the other side, angle DBE is also there. And I want it to go away. Subtraction. Am I taking away the exact same thing from both sides? Yes, so this would be a property of subtraction property of equality. There we go. Subtraction property of equality. Fantastic. Let's look down at number 4. Is number 4 a proof? No, we have a solving problem, but we're going to have to use an idea that we used here in our proof in order to be able to solve this problem. So let's look at what we've got. It says solve for x and find the measurement of angle ROS and the measurement of angle SOT if the measurement of angle ROT is 408 minus 11x. Well, I'm going to let ROS be a dark blue angle. Here's my angle ROS. And then we also have angle SOT. I'm going to use a lighter blue for SOT. Here's my angle SOT. And they said that the measurement of angle ROT, well, that's a huge angle. It almost looks like a straight line. But this angle right here is ROT, going from this side all the way around to over here, is 408 minus 11x degrees. And my first question to you is, how many angles are being shown in that picture? 3. Talk to me about those 3 angles. Is there anything special about them? Do they have a relationship to each other? What happens if I put the 2 smaller ones together? I get that bigger angle. What was it off the red paper that allowed me to take 2 smaller angles measurements, add them together, and get a larger third angle? Angle addition postulate. That's what we're going to use to be able to set up this problem. Angle addition postulate. What are the names of the 2 smaller angles that are going to be put together here? SOT and SOR, or ROS. So the measurement of angle ROS plus the measurement of angle SOT. When I add those 2 smaller angle measurements together, I get what larger angle? ROT, measurement of angle ROT. To be able to make that statement right there, to write down that equation, I'm using the angle addition postulate. And then I can come in here and I can put something in the place of the measurement of angle ROS. What can I put in its place? 4x minus 20. What are we using when we do that? Substitution. Bring down my plus sign. We're going to substitute again. What can go in for SOT? 3x plus 14 equals, what goes in for ROT? 408 minus 11x. Beautiful. Let's stay just on the left side of the equal sign for right now. Is there anything that I can simplify, any like terms that I can put together over there? 4x and 3x. What do I get when I combine those? 7x. Anything else I can combine? Negative 20 plus 14. What is negative 20 plus 14? Negative 6. So 7x minus 6 equals 408 minus 11x. So what we just did there in that step was we simplified. I like that. You said I need to add 11x to both sides. We want to get our x's together. That's not the only way I can get my x's together. What else could I do if I didn't want to add 11x to both sides? I could subtract 7x from both sides. That would get my x's together also. Either one is right. What property am I using right now? Addition property of equality, yes. So I add the 7x and the 11x together. I get 18x minus 6 equals 408. Now what? Add 6 to both sides. What are we using to be able to do that? Addition property of equality again. So I have 18x equals 414. What now? Divide both sides by 18. What are we using? Division property of equality. And x is how big? 23. There's one of the things they asked me to find. It said solve for x. We just did that. Now I need to find the measurement of angle ROS, which is 4x minus 20. Thank you. So I'm going to have 4 times 23 minus 20. What do I get when I simplify 4 times 23 minus 20? 72. So angle ROS is 72 degrees. And then we still need to find the measurement of angle SOT, which is 3x plus 14. So measurement of angle SOT is equal to 3 times 23 plus 14. We get 83. You're absolutely correct. Very nicely done, ladies and gentlemen. And what was the key to being able to set it up at the beginning? What did I have to use right at the very beginning? The angle addition postulate. Without that, I couldn't have done this problem. We're going to go to the very last page now, page 18. We've got one more proof and one more solving problem. And there's something kind of nice about this last proof. What do you notice is already filled in for us? Every single statement is already filled in for us here. So we just need to come up with the reasons. Something interesting I noticed here, though. What do we always put as our first statement? Is that what they put for the given? Or sorry, for the first statement? No. Where's the given information here? Not until we get down to step 5. That's kind of weird. So I know my step 5 reason is because it is given. Do they have what we're trying to prove in the correct spot? Yes. Measurement of angle 1 equals measurement of angle 4. Measurement of angle 1 equals measurement of angle 4. So that's where I expected it to be. Do you think it's wrong that they didn't state that given information until step 5? It's not wrong. It's not typical. It's not normal, but it's not wrong. If all of this stuff up above isn't coming from my given information, then what is it coming from? The picture. I'm allowed to look at this picture and make statements just like I can with my given information. So they decided to start off with the picture. What's the first statement they made? Angle 1 and angle 2 are a linear pair. Anything else? Angle 3 and angle 4 are also a linear pair. Is that true based on what you look at on the picture?
Yes.
So I want you to look at your red paper. What would allow me to just look at the picture and say, aha, that's a linear pair? Definition of linear pair. You okay? Something off the floor?
Yeah.
Definition of a linear pair. Definition of a linear pair is what I'm allowed to use, if I could spell it right. There we go. Definition of a linear pair. When I first introduced you guys to what a linear pair was, I talked to you about what we would look for in a picture. I need two angles that are adjacent. They share a side, like this right here. And their non-common sides, like this one and this one, form opposite rays. So when I look at the picture and I pick out, aha, that's a linear pair, that is using the definition of linear pair. What do they say in statement number 2? Well, we weren't given that information. The only thing above it that we've already said is that angles 1 and 2 are a linear pair. And now we're jumping to say they're supplementary. We said that angles 3 and 4 form a linear pair, and now we're jumping to saying they're supplementary. Linear pair theorem. So definition of a linear pair, I looked at the picture and I saw a linear pair. Linear pair theorem, I know already that I have a linear pair, and I want to say something more about them. I want to say that they're supplementary angles. All right, let's see what we're saying in statement number 3. Statement number 3, we said angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. But in the step right above it, we were saying that they were supplementary. Why can I jump from saying that those angles are supplementary to now turning them into equations? Definition of supplementary angles is absolutely correct. Definition of supplementary angles. All right. So the first statement we could make about them being linear pairs came from the picture. That was the definition of a linear pair. Then we said those angles forming a linear pair are supplementary. That was my linear pair theorem. Once I've identified that they're supplementary, I can write equations with them where I add them and equal them to 180. That's my definition of supplementary angles. How many equations do I have in step 3? I have 2 different equations, 2 equal signs. How many equations are there in statement 4? There's only 1. Angle 1 plus angle 2, that's still here. And on the other side, I have angle 3 plus angle 4 right here. Well, angle 1 plus angle 2 is 180. Angle 3 plus angle 4 is also 180. So are these things actually equal to each other?
Yes.
Why am I allowed to say that? What did we say? It's not an addition postulate, but I like what you're thinking. The reason it's not an addition postulate is because I already had plus signs up here. So that's not something new that I've introduced. What I did was I took 2 equations and I combined them into 1 equation. It's almost like I removed the 180 and I put this in its place. Substitution. Or what else could I possibly use here? Transitive property. Substitution property or the transitive property. I feel comfortable that we understand why this could be substitution. I took the 180 out. I put something that was equal to 180 in its place. Transitive property, remember, I'm only allowed to have 3 objects. We're treating this addition right here, angle 1 plus angle 2, as a single object. And then I have 180. It shows up in 2 spots, but it's still just one thing. And then we're treating angle 3 plus angle 4 as a single object together. So I have this is equal to 180. 180 is equal to this other thing. So the first and the third things have to be equal to each other. We already know our reason for statement number 5. That was given to us. So now I want to compare and contrast statements 4 and 6. Compare these two. Did anything stay the same? Angle 1 plus the measurement of angle 2, that stayed the same. Did the other side of the equal sign stay the same also? What changed? Angle 3 got, what was the word that you used, Diedrich? Substituted. So what are we using here? Substitution property, yes. This is not a situation where I could use transitive property because I took one thing out of the middle of an equation and I put something else in its place. It's not on the other side of an equal sign by itself.
So why was angle 2 substituted in angle 3?
Good question. Where else in this equation do you see measurement of angle 2? On the other side. Look down at my last statement, what I'm trying to prove. Angle 1 is on the left, still on the left in my last statement. Angle 4 is on the right. It's still on the right in my last statement. What did I get rid of? Measurement of angle 2. Am I allowed to get rid of it from both sides? Only if it's identical on both sides. Could I have done that up here? Could I have taken away the exact same thing from both sides in step 4? No, because I didn't have the same thing on both sides. We used our given information that angles 2 and angle 3 are the same size, so I can swap one out for the other, and so we swapped this out for angle 2. Now I have identical things on both sides, and I can take it away from both sides using what? Subtraction property of equality, yes. Very nicely done. All right, yes. Thank you so much. We have one final problem to work through. Is it another proof? No, we have another solving problem here. We are supposed to find the measurement of angle x, or sorry, not angle x, solve for x is what it says. And then we need to find the measurement of angle RSU. Well, let me go to the picture and find RSU. Here's R, here's S, here's U. So this big angle right here is RSU from one side to the other. Are we told how big that angle is anywhere? Where? Like, how much is it? How big is it? 4x plus 100. We are told that right here in our given information. 4x plus 100 degrees. Well, I know that angle TSU, T up to S, and then over to U, this angle right here is 5x plus 65 degrees. What else do I know? Measurement of angle RST is 20 degrees. Well, here's RST. What am I going to have to use to solve this problem that's off that red page? Angle addition postulate. Angle addition postulate, I have to use the names of the angles. And then after that, I would be allowed to do some substitution. So what are the angles that are the smaller angles being added together? Measurement of angle. RSU is one of the smaller ones. RST. What's the other smaller angle? TSU. So RST and TSU get put together to make what larger angle? RSU. It's okay. That is my angle addition postulate. Now I'm going to use some substitution. What can I put in the place of RST? 20. What goes in the place of TSU? 5x plus 65. And then what goes in for RSU? 4x plus 100. Aren't we going to do what from what side? Yes, we will. First, though, I want to simplify anything. I want to combine any like terms together that I might have. Do we have any like terms over on the left? 20 and 65. So let's put those together first. What do I get when I combine 20 and 65? 85. So 5x plus 85 equals 4x plus 100. Now what do I do? Subtract 4x from both sides. So that gives me x plus 85 equals 100. Now what? Subtract 85 from both sides. What am I using to be able to do that? Subtraction property of equality. What is 100 minus 85? So x is 15. That's one of the things I was supposed to find. The other thing I need to find is the measurement of angle RSU, which is 4x plus 100. And we're going to take that measurement for x that we just found of 15. We're going to substitute it in. So 4 times 15 plus 100. And what do I get when I do 4 times 15 plus 100? We get 160 degrees. Absolutely correct. So we found x, and we found the measurement of angle RSU. Absolutely fantastic, guys. Tomorrow, what do you need to have for me? Homework. If you need another copy, it's over here in this red organizer. It's the very bottom paper here. And then tomorrow we will begin studying for your test, which will be Thursday.